This is the 2024 Deferred Paper 1, and it's question 6, which is a calculus question. So let's read it first. The function hx is defined. Here, hx is the sine of 2x. Part I says to write down the h dash of x, the derivative of hx. So this is very clear what they're asking. We've got to differentiate. So write down your function hx is sine 2x and differentiate. So h dash of x. Well, sine goes to cos according to the tables. But there's something else going on here. This is what I call a main plot and a subplot. The main plot is that there is sine of something. So that means it goes to the cos of something according to the tables. But then within the main plot, there's a subplot going on, 2x here. And we've got to take that separately and differentiate. So 2x goes to 2. And then you multiply your answers. That's the chain rule. That's how it works, the chain rule. So again, there's a main plot, sine of 2x goes to cos of 2x. So sine of the thing goes to cos of the thing, according to the tables. And then in the subplot, you've got 2x going on, so 2x becomes 2 if you differentiate. And you multiply your answers. That's what you do with the chain rule. Multiply the two answers. So your final answer is 2 cos of 2x. So watch out for that too, because again, that's where people tend to go wrong. They forget that too. Next part, use integration. So there's what I call a trigger word. When you see that trigger word, you know what to do. You integrate. Average is another trigger word in the exam, and we'll see later that means there's a formula for average which you need to learn because it's not in the tables. Okay, so integration to find the average. So here is the formula for average value. Not in the table, so this must be learned off. 1 over b minus a integral between a and b of the function dx. So it's basically the integral of the function between two limits a and b, and outside it's 1 over b minus a. Now, when you're getting the average, the two limits are given to you between this value and this value. So that's the lower limit, that's the upper limit. So straight away that's a and b. So put in naught, put in pi over 6. Naught and pi over 6 again here. So it's 1 over pi over 6 minus naught, which is 1 over pi over 6. Now dividing by a fraction is the same as multiplying by the fraction upside down. So turn that upside down and you get 6 over pi. Just be a little bit careful here now. With sine 2x, well, again in the tables, if you look up sine, it goes to minus cos when you're integrating. So be careful here, we're integrating, not differentiating. So look at the right page of the tables. So sine goes to minus cos. And again, we've got this subplot thing going on. We've got to deal with the 2x separately. Now in differentiation, you multiply by 2 as we saw earlier. But this is the opposite integration, so you divide by 2. So don't forget to put in that divide by 2 there. That's again a common mistake. People leave out that. So it's minus cos 2x over 2, and then it's top minus bottom. So these are the two limits. You draw a straight line here to hold onto the limits because the integration is done now, and you have your top limit minus your bottom limit. Okay, so next line. We can tidy up slightly. That 2 goes into 6 3 times, so it's 3 over pi, and you've got minus cos 2x then, and top and bottom limits. Now the next part of the question, you put in the top limit for x, you sub it in, you sub in the bottom limit, which is 0, and you subtract your two answers. Now be careful here, there's a lot of minuses. So it's minus that, minus that. You sub them in and work them out on your calculator or whatever, or you might know them in the tables. These are special angles anyway. That's the cos of 60, which is a half, so it's minus a half. Minus minus is plus. Cos of 0 is 1. So you end up with 3 over pi into a half, which is 3 over 2 pi, and that's your answer. Okay, so that's the answer to that part. I have an alternative over here for people who are interested. It's shorter. It's a nice shortcut to learn if you're interested, so just watch how it works. When you get to this stage here, because of the minuses are awkward, as I say, a lot of minuses going on. So there's a rule, there's a shortcut where you can just get rid of the minus and swap these two around. So if you end up with a minus in front, you can just get rid of the minus and swap these two around. So that's what I've done down here. The minus is now gone, and I've swapped these two around, 0 on top now, and pi over 6 on the bottom. And I just put in top minus bottom as usual, cos of 0 minus cos pi over 6. Much quicker, I think. if you're interested in learning that rule or that shortcut. And that's it. It's 1 minus a half, which is a half by that same answer. Okay. Now to part B. And this was an unusual part B, so we'll just break it down. There's a function given here. This is the function. It's just given as a graph. But they don't tell you what fx is. There's no equation or anything like that, which makes it unusual, I suppose, compared to a lot of the questions. And we're told that that's the graph, as I said. Now, the graph is made of 3 straight segments, this piece, this piece. So there's 3 pieces and this piece. And we have to answer the question down here, which is, for what range of values of x is f dash of x negative? Now, a common mistake here would be students not to read it properly. They say, okay, f is negative. Look, the function is negative below the x-axis from here to here. But again, that's not what's being asked. If you read it very carefully, it's the f dash of x is negative. It's the dy dx is negative. Okay, so how do we handle that situation? So f dash of x, you're supposed to know again at honours level the very basics of what dy dx is. If you look at the first principles, it's the slope of a tangent. You have to know that at all times because they can ask it that way in the exam. Find the slope of a tangent. So just a kind of a bit of revision here before we tackle the question. Take any curve here. The dy dx actually means, if you look at it on a diagram, it's the slope of that tangent. That's what it is, m. So it's slope of tangent. Okay. Now I've prepared a page here as well before we do the question, just as a revision. If you look at slopes, so there's the function y equals fx, some function, whatever it is, y equals fx. I've labelled it there. If you look at slopes at different points, for example here, let's just estimate the slope, rise over run. So there's the rise, there's the run. It's roughly the same, so it's 1. The same ratio. So rise over run is roughly 1 there. We'll say 1 over 1 or 2 over 2, whatever. So the slope is 1. Jump over to this one here. The slope is 0 because it's flat. There's no rise at all. So it's 0 over something. Okay, so it's just 0. Take this one here, it's 0. So at a max and a min, the slope is 0. Take this one here. That's leaning forward again. The slope is half because it's probably, look, rise over run. The rise is smaller than the run. So it's a fraction, probably 1:2 or something like that. So we're just guessing there. Now the important point is this: when the line is leaning backwards, what's the slope? Well, now the rise over run, you're going back. The run is back and up. So it's rise over run. When you go back, that's a minus. So it's a minus slope. And you'll find that that's a general rule for when slopes are leaning forward, they're plus. When they're leaning backwards, they're minus. If you pick any point along that curve and test it yourself, pick that point for example, you know, it's leaning backwards, so it's a minus slope. That's leaning forward, so it's a plus slope. And at the top and bottom, then max and min, it's 0. So that's very important to know. You can't really tackle this question we're doing right now without knowing that. So let's go back now with hopefully renewed confidence and look at it again. He's looking for where the slope is negative. In other words, where the line is tangent is leaning backwards. So we can see now straight away. I mean, it's 0 there. If you kind of drew a kind of a tangent along here, its slope is 0, or along here it's 0. But if you drew one along here, it's leaning backwards, so it's minus. And there's your answer. So basically, as long as the x value is between 1 and 2, it's leaning backwards. Simple as that. So it's a very simple answer once you know what you're doing. But if you didn't know that background information, you'd find this question impossible. Okay, so that's that. Now, the last part. A is a constant, where A is between 0 and 5. So A is some number between 0 and 5. And we want to get the area between 0 and... okay, well, first of all, I put in this bit area. We weren't told it was area. So this is what we were given, a function, or an integral, between 0 and A of fx dx. But we should know that when you're given the integral of some function between two limits, that is an area. That's the formula for area under a curve. Okay, so for example, if A was, just say A was this value, between 0 and A. If I get the integral between 0 and A, what I'm actually getting is the area in there. I call it the plus area there. I'm getting that actual area. If I got the integral from 0 to 3, or 0 to 3 for example, what am I getting? Well, I'm getting all that area in there and all that area in there as well. It's always the area between the function and the x-axis. So I'm getting that. Now, if you know about areas and integration, integration is a powerful tool for getting area. It's actually too powerful almost, because it gives you, it's extra sensitive. It even gives you minus areas. It treats this as a minus and this as a plus. It's too accurate almost, and which means that you're in trouble now, because if you get the area between here and here, you get 0, because the plus area by symmetry cancels out the minus area there. So to make a long story short, if I integrate between here and here, I get a plus number of some sort. If I integrate between here and here, I get 0. If I integrate between here and anything beyond 3, well, the minus is now going to be bigger than the plus area. So I'll get a minus overall. Anywhere between here and anywhere above 3, basically, the minus area is going to be bigger. So what are we actually asked? Write down the range of values of A, which is the top limit there, for which the expression is positive. Well, we've answered it now because the expression is positive. If I get the area from here to here, we'll say it's positive. If I get the area from here to here, it's just the plus area plus that little bit, still positive. But if I get the area up to 3, it's going to cancel out to 0. So 3 or beyond is out of bounds, basically. So basically anything less than 3, and we're overall plus. We're overall winning, we'll say. So the plus area here plus the minus area here, as long as the minus is smaller than the plus, we're winning. The overall area is plus. So the way to say it is simply as long as A is less than 3. So as long as A is less than 3, that's full marks, by the way. Just saying A is less than 3 is full marks. I just wrote all this to explain it. So when A is 3, the plus and area and minus area cancel. When A is 3, the plus area is bigger. When A is greater than 3, the minus area is bigger. And finally, as long as A is less than 3, the plus is winning over the minus. So the overall area is positive, which is what we're asked basically, this function positive. And that's the end of question 6.